So this video is going to cover chapter 13 of geometry, which focuses on trigonometry. It's going to go all the way from 13.1 to 13.5. So by the end of this video, you should know the basics of trigonometry. And we're going to start out with the trigonomic ratios. So tangent is going to be the ratio of the length of the opposite side divided by the length of the adjacent side in a right triangle. So if we have our right triangle and we pick that we're focusing on this angle right here, then your tangent is going to be the opposite side, which is here, we can call that y, over divided by the length of the adjacent side, which is here, we can call that x. So it's going to be y over x is your tangent. So here are all of the trigonometric ratios. So if we have our right triangle and we say that this is angle A, then this is going to be the opposite side. This is going to be the adjacent side. And this is going to be the hypotenuse. So for sine, you're taking, so sine of this angle right here is going to equal the opposite over the hypotenuse. And then cosine, which is abbreviated, so these are all abbreviated, is going to be the adjacent side over the hypotenuse. And then tangent is going to be, as we said, the opposite over adjacent. And you can remember this with a little mnemonic, SOHCAHTOA. So this S stands for sine, opposite hypotenuse. So sine, opposite over hypotenuse. Then cosine, adjacent over hypotenuse. Cosine, adjacent, hypotenuse. And then tangent, opposite, adjacent. So SOHCAHTOA, and then you'll know your trigonometric ratios. So your angle of elevation is going to be the angle from the horizontal up to the line of sight. So, for example, if we have horizontal and then we have an angle here, that's going to be the angle of elevation. An angle of depression is an angle, it's essentially just down to the line of sight. So the angle from the horizontal down to the line of sight. So if this is our line of sight. So if we're given the following triangle and asked to find what is sine of A, so first we can see that this is going to be a Pythagorean triple, so we know that the hypotenuse is going to be 5. We can also do that with the Pythagorean theorem, which is going to be c squared equals a squared plus b squared, c squared being the hypotenuse, a squared and b squared being the sides, the legs. So we know that sine is going to be opposite over hypotenuse, and since we now find the hypotenuse, we can just plug in our values. So sine of A is going to equal, so 4 is going to be your opposite because it is opposite of the angle, over 5. So that's your value. So this first conjecture is really cool. It's a way of finding the area of a triangle with just knowing two sides and the angle between them. So it says that the area of a triangle is given by the formula A equals 1/2 A times B times sine of C, where A and B are the lengths of the two sides and C is the angle between them. So say we know that this angle is going to be 60 degrees, and we know that this side is 3 and this side is 2, we can actually say that the area is going to be 1/2 times 3 times 2 times sine of 60. Okay, so then this next conjecture says that for a triangle with angles of measure A, B, and C, and sides of length A, B, and C, so A opposite A, B opposite B, C opposite C, then we can say that sine A over length A equals sine B over length B, and sine equals sine C over length C. So essentially, if we have, so this is what the triangle would look like. We have these angles, A, B, and C, and we have the lengths opposite them. So that can help you visualize what this actually means. So if we're given this triangle and we're asked to find the length of B, we can use our law of sines. So we know that sine A over length A equals sine B over length B, and that's all we need of it. We don't know either the angle or the length for side C, so it's not going to be useful here. But we do know both the angle and the length for side A, so we can plug that in. So it's going to be sine of 59 degrees over 350. And then we can plug in, we know our angle for B, so that's going to be sine 38 degrees over B. And then we want to cross multiply as we do with proportions, and we're going to end up with B sine 59 equals 350 sine 38, and then we can divide by sine 59 to get 350 sine 38 over sine 59, and then you can plug that into your calculator and you're going to get approximately 251 centimeters. So this next conjecture is the Pythagorean identity, which says that for any angle A, sine squared of A plus cosine squared of A equals 1. This is a really important thing to know, and you're going to keep using it. You're even going to use it in calculus. So this is an important one. Then there's the law of cosines, which is also very important. It says that for any triangle with lengths of A, B, and C, and with C the angle opposite the side with length C, then C squared, length C squared, is going to equal A squared plus B squared minus 2AB cosine C. So given this triangle and told to find the length of C, we can use our law of cosines. So that's going to be C squared equals A squared plus B squared minus 2AB cosine C. So all there is to do here is really to plug in our values and then solve. So we know that since this is A, this is angle A, this is going to be length A. So we have 52 squared, and then that means this is going to be B, plus 45 squared minus 2 times 52 times 45, so that's A and B again, cosine, and then we know that cosine, so of angle C, which is here, so that's going to be 36 degrees. And then we can essentially just plug this all into our calculator and we'll get a value for C squared. And this value is going to be 942.8. And then we can take the square root of both sides, and that turns out to be 30.7. So there you have your value of C.